Have you ever wondered how many ways you could climb a staircase if you could take one or two steps at a time? Is it as simple as counting steps or is there more to it? Well, guess what? It's not just a riddle, it's a real coding challenge that pops up in tech interviews all the time. Today we are tackling the climbing stairs problem, a fan favorite among coders and interviewers alike. Whether you're preparing for a big coding interview or just sharpening your problem solving skills, I've got you covered. The secret to solving these problems lies in recognizing patterns and breaking it into solution that is smaller, manageable steps. It's all about leveraging dynamic programming to take steps to save time and effort. This problem can be solved using dynamic programming where we break it into smaller, manageable subproblems. The trick is in recognizing a pattern to get to n steps. You can take one step from n minus 1 and take two steps from n minus 2. So the total number of ways to reach n is the sum of the ways to reach n minus 1 and n minus 2. Actually, it's a Fibonacci sequence in disguise. Let's turn this insight into code using dynamic programming in C#. We'll store intermediate results to avoid redundant calculations. This is the entry point of the program. The main method is where the execution starts. We initialize the variable n with the value of 5, which represents the number of steps in the staircase. You can change this value to test different inputs. This line calls the climb stairs method with the value of n and print the result. The dollar sign before the string allows string interpolation, embedding the value of n and the results directly into the message. Then we define the method climb stairs, which calculates the number of distinct ways to climb a stair with n steps. If n is equal to 1, that is, there is only one way to climb, that is a single step. If n is equal to 2, there are two ways to climb, that is 1 plus 1 or 2. This prevents unnecessary calculations for this straightforward scenario. Next, we create an integer array of array dp of size n plus 1. This array will store the number of ways to climb up to each step, avoiding redundant calculations. Initialize dp array of 1 to 1 because there is only one way to climb one step, and then initialize dp2 because there are two ways to climb to two steps. Take two single steps or one double steps. We start a loop from step 3 to step n. This loops calculate the number of ways to climb each step by building on the results of the previous steps. For each step I, the number of ways to climb is the sum of dp I minus 1 ways to climb to previous steps and take one step, and dp I minus 2. This follows the Fibonacci-like recursion relation. Alright, then we return the value stored in dpn, which represents the total number of ways to climb n steps. Solving this problem is like tackling real life challenges. Take it step by step, reuse whatever you have already learned, and you'll eventually find your way to the top. If you have loved this breakdown, smash that like button, share it with your fellow coders, and subscribe for more bite-sized coding explanation. Got a question or want me to tackle a specific problem? Drop a comment below and I'd love to hear from you. Until next time, keep climbing, keep coding, keep crushing those challenges, and I'll see you soon.